In this video, I'm going to be going over the multimeter quiz. Question 1. With the multimeter set to read DC voltage and connected to the indicated test points, what is the reading? So we have 24 volts up here, and we say that the red test point, this one, is connected to that 24 volts, and we have 0 volts down here, and the black is going to be connected to that. For multimeters, red is used to measure positive, and black is negative or ground or common. And so with that arrangement, we would see a reading of 24 volts. If we switched the leads, it would switch the sign, and it would be negative 24 volts. In this case, it's not negative, it is positive 24 volts. This question, what happens if we switch the leads? Black is up here, red is down here. Now it's going to be negative 24 volts. Question 3. Ooh, there's a resistor in here. So the multimeter is set to read DC voltage. We've got red on the 24 volt side of the resistor and black on the 0 volt side of the resistor. All of the voltage drop is going to happen across the resistor. And so we're going to see 24 volts. All right, now we have a resistor and a switch. And we can see that this switch is open. With the multimeter set to read DC voltage and connected to the indicated test points, what is the reading? Okay, in question 3, we had voltage drop across the resistor because we had current flow through the resistor. With this open switch, there is no current flow through here. Remember, the current wants to go from high voltage to low voltage. So there is no current flow through here. And because there's no current flow, there's no voltage drop across the resistor. So the voltage here is 24 volts, and the voltage here is 24 volts, relative to this 0. The difference between this voltage and this voltage is 0. So we're going to read 0 volts DC. Question 5. It's getting more complicated. With the multimeter set to read DC voltage and connected to the indicated test points, what is the reading? So we've got red up here, we've got black here, we have this resistor, happens to be 470 ohms. This switch connects it through this resistor to ground, or 0 volts. These resistors both have the same value. So we have current flow through this path. It's flowing through each of these resistors in series. So we have voltage drop across each resistor. Because these resistors are the same value and are in series, we have the same voltage drop across each of them. So our voltage goes 24 volts, dropping down to 12 volts here. 12 volts drops through this resistor down to 0 volts. So the difference between 24 volts there and 12 volts here is 12 volts. Question 6. We introduce a relay. The push button, that's this thing right here, this little finger is going to push this button, which only makes contact when pressed, has not been pressed. The multimeter is set to read DC voltage. The red lead is connected to A1, this contact here, and the black lead is connected to A2, right here. What is the reading? All right, well, let's trace this out and see what we can figure out. If I am current and I'm trying to get somewhere, this button has not been pressed. So if I come down here, I can't get through there. So there is no path for current to flow there. So looking down here farther, if I come over here through this switch, I can't get through. There is no path for current to go there. So there is no current flowing in here. There's no way for current from this 24 volts to get down to this 0 volts. So if I look A2 just has a wire connecting it to ground. The voltage here is 0. This is the coil of wire in the relay. Because there is no current flow through that coil, the voltage here is the same as the voltage here. They're both 0. A1 and A2 are both 0. The difference between them is 0. 0 volts DC. All right, here we have the same relay. The push button, which only makes connection when pressed, is being pressed. The multimeter is set to read DC voltage. The red lead is connected to A1, the black lead is connected to A2. What is the reading? So this happens to be a very important use of a relay. It's a self-latching relay. So current can't flow this way, but when we push this button down, it makes contact. Current can flow through this coil. This coil is an electromagnet. When that happens, it flips this switch up. Current flows through this coil and down to ground. It doesn't relate to this question, but when this switch flips up, current can then flow across this switch all the way around here, up here, and through this coil. And it latches this switch, this relay, it latches it on. Now when you let go of this switch, current will still flow through this latched on relay and keep it latched on. But back to this question, we have current flowing through here. The impedance or resistance is all through this coil. This is a short piece of wire here, this is a short piece of wire here, this is a long piece of very thin wire wrapped around this electromagnet. So all of our voltage drop, practically speaking, we're going to see across of this coil. So on this side, we're connected to 0 volts over here at A2, and on this side at A1, we're connected through this push button to 24 volts. We're going to see a 24 volt drop from A1 to A2. Question 8. The push button, which only makes connection when pressed, has just been pressed and is now released. The multimeter is set to read DC voltage. The red lead is connected to A1, the black lead is connected to A2. What is the reading? So this is the same situation as before, except now this has been released. Now remember, once this has been released, this relay is still latched on. So we've got current coming down here. It can't come through here because this has just been released, but it's coming down here. Because this is latched on, this switch is flipped up. It can flow across here from 11 to 14, all the way around up to A1, through that coil, through that electromagnet to A2, and back to ground. And so, A2 is at 0 volts. A1 is still at 24 volts. I mean, yes, it has to go all the way around here. This is, a few inches, but this is many, many inches of very fine wire. All of your voltage drop is going to be across this coil. And so we have a drop of 24 volts from A1 to A2. All right, now we have a double pole double throw relay. The previous questions we had a single pole double throw relay. Oh, I said that wrong. The previous questions we had a single throw double pole relay. All right, the push button, which only makes connection when pressed, has been pressed. The multimeter is set to read DC voltage. The red lead is connected to 11, and the black lead is connected to 21. So the red lead is up here, and the black lead is here. And this button has not been pressed. So what do we have happening? Current is going to want to get to 0 volts. Coming down here, it can't get across here because this hasn't been pressed yet. Coming down here, it can't get across here because this leads to 12, which doesn't go to ground. Down through here and coming across, it can come and get to ground. So our current is going to make its way through this resistor, and at this point it has a choice. It can go through these 470 ohms this way, or it can go this way through effectively 0 ohms. It's all going to go this way, the path of least resistance. So we're going to see a full 24 volts of drop across this 470 ohm resistor. So with our red lead connected to 11 and our black lead connected to 21, we're going to see that 24 volt drop across this first resistor. Okay, now we have the same circuit. The push button, which only makes connection when pressed, has been pressed and is now released. So this relay is latched on, right? Because when you excite this coil, all of these switch up and current can flow through 14 and around and keep this relay latched on. The multimeter is set to read DC voltage. The red lead is on 24. That's over here. And the black lead is on 22. That's here. What is the reading? All right. Well, with this latched on, this won't be in this position. It'll be going horizontally across here. And so the voltage all along here is going to be at 0. So 22 is reading 0 volts. Now let's figure out what 24 is reading. With this latched on, current can't go through here because we've just released this button. But it can come through here, across to 14, down and around through A1 and A2 to keep this latched on. It can also come and flow through this resistor, this first resistor. When it gets through this first resistor, it has a choice. Would it go this way, or both? If we follow this way, this is latched on, so this is flipped up, and this leads to nothing. It can't get to the 0 volts from here. So none of it is going to flow that direction. The remainder is going to flow down this way. And now we have 2 resistors in series. So it's 24 volts from here down to 0 volts. These resistors have the same value, so it's 12 volt drop across this resistor and 12 volt drop across this resistor. This point here is electrically connected to this point, 24. So 22 is at 0 volts, this is at 0 volts, this is at 24 volts, and in between this resistor is at 12, these resistors is at 12 volts. And so 24 is electrically connected to that 12 volts. So we're going to see from 12 volts to 0 volts a 12 volt difference. 12 volts.